Okay, so here we've got a two-sample hypothesis test. On the left we've got a 3-point percentage for the last 11 NCAA championship games, each with the respective 3-point percentages for the teams that won. For the teams that won, I've listed them on the left versus the teams that got second. So you go to Stat List Editor and you enter everything in the first column and the second column into List 1 and List 2 respectively. Then you go to your two-sample t-test menu as in the above picture, and once you get that you hit calculate and you end up with the two results shown in these two bottom pictures. Our hypothesis, that is the null hypothesis, is mu1 minus mu2 equals 0, and the alternative hypothesis is mu1 minus mu2 is greater than 0. So once we enter in the two-sample t-test, we've got our results here, and then we need to find our critical value. And our critical value is found by using inverse t of 0.05 and 20, or our level of significance and our degrees of freedom. I'm solving this to the 95% confidence. This gives us the critical value of 1.724, and then if we want to find our test value, I've entered that equation. That's where we go x bar 1 minus x bar 2 times null hypothesis, which is just 0, so we don't even need it, divided by the square root of sx1 minus sx2 squared. Square root, sorry. Our test value gives us 8.861. Perfect, and so now we can enter that into our graph right here. So our critical value is 1.724. The test value is 8.861. Now that we have our test and critical values on a graph, we can see that the test value is clearly way over the critical value and in the critical region. So we are going to reject, and there is enough evidence to claim that winning a basketball game depends on 3-point percentage. And that is how you do a two-sample hypothesis test.